Good morning. Today I am going to teach you about multiplexer. What is digital multiplexer? It is nothing but selecting one data out of many data to the output, so that there are so many data, say I0, I1, dot dot, IN. So out of this n data, I need to select at the output only one data at a time. Say IX, which is intermediate data, IX. So we need some control signal here, which must select out of this data only one data to the output. So control signal is called S, and this is called multiplexer. Now, to understand this concept of multiplexing, we need to understand the AND gate properly. What happens in AND gate? Suppose this is the AND gate. There are two input. One input is say data D, another input is say control signal S, and output say F. So when S is equal to 1, then this data will be transferred to F. F will be equal to D. When S is equal to 1, then whatever data D is 0 or 1, it will be transferred to the output. Clear? And in the case of this, when here is D and we have a NOT gate, then S. This AND gate, we have control signal S. So when S is equal to 0, then this will be 1, and this data will be again transferred to the output F. So F will be equal to D. So when one input of inverted AND gate is inverted control signal, then it transfers data D to the output when control signal is 0. So this two concept works to transfer input data to the output. When control signal is 1, in this case data is transferred, but when control signal is converted to AND gate with a NOT gate, then when S is control signal is 0, then it will transfer to data to the output. Now, if you want to make 2:1 marks, what do we need to do? So we must connect S. So when S is equal to 0, so let's understand first its truth table. When S is 0, the output function F must be equal to D0. And when S is equal to 1, S must be equal to D1. Suppose we have two data D0 and D1, and S is 0, it transfers D0 to the output, and when S is equal to 1, this is the truth table. Now, for this truth table, we must connect this D0, and when S is 0, so S must be connected with NOT gate. So that is the S. So when S is going to inverted output here, so output becomes D0 for S equal to 0. But when S is 1, so D1 data must go to another AND gate, and output is here D1 must go to the another AND gate. So when S is equal to 1, it transfers D1 to here. This is D1. So here D0 and D1 we are getting. D0 will be getting when S is equal to 0, and D1 here will be getting when S is equal to 1. So both this will be transferred to the one OR gate, and this will be equal to F. So this is the circuit for 2:1 marks, and we can write its equivalent function. So it's nothing but when S is not inverted, then D0 comes, and plus when S is non-inverted, then D1 comes. So F is equal to S bar D0 plus S D1. Let us understand working of 4:1 multiplexer. 4:1 marks. So first let me understand the block diagram. Block diagram should be like that. 4:1 marks. Here should be 4 data, D0, D1, D2, D3, and output should be function f, and control signal there should be 2 S1 S0 because these two control signal generates 4 data. So out of this, if you make a truth table, when S0 S1 S0 is 0 0, then data output F must be selected, D0 must come to the output. When S1 S0 is 0 1, then it selects D1. When it is 1 0, it selects D2. When both are 1 1, it must select D3. So this is the truth table for 4:1 marks. So this control signal S1 and S0 must go to one AND gate, whose input data is D0 and its input is inverted. So NOT gate will go to S1 and again one NOT gate and S0, such that it will transfer D0 here. Similarly, another AND gate whose input will be D1 and input control signal will be 0 1, means S1 bar S0. So we can write here S1 bar and another input is S0. So it will transfer D1 here. Another AND gate, third AND gate, input must be D2 and two of its input must be 1 0. Say S1 and another will be 0, means S0 not, and output will be D2. And fourth AND gate is visible here, 1 1. So one input should be data D3 and another input must be S1 and S0, so that output will be D3, and all this must be connected to one OR gate, will be output F. So in this case, output F, you can understand how to write this F. F will be equal to S1 bar S0 bar into D0 plus S1 bar S0 into D1 plus S1 S0 bar into D2 plus S1 S0 into D3. So these four mean terms, this is the mean term first, multiplied by D0, second mean term multiplied by D1, third mean term multiplied by D2, and fourth mean term S1 S0 multiplied by D3 will generate the function output for the 4:1 multiplexer. So this is all about multiplexing. Now you can generate higher order of multiplexing also using lower order multiplexing. Like on example I am giving. So here is multiplexer 4:1 multiplexing using 2:1 multiplexer. 4:1 will generate 4:1 multiplexing using 2:1 multiplexer. So here is the truth table for 4:1 multiplexing. When control signal S1 S0, S0 is lowest significant bit, S1 is most significant bit. Signals are input are 0 0 0 1 1 0 1 1, output D0 D1 D2 D3. So here is the two level. First level, that is 2:1 marks. Second level, that is 1:1 marks. So because we need to generate 4 using 2:2, so we'll divide this 4 by 2 Answer is 2. So in first level there should be 2:1 multiplexer, so that it will take 4 data, D0, D1 in first and D2, D3 into second. So you can see here when S is 0, S equal to S0, S not equal to 0, it will transfer D0 to here and here D2, because the same S0 is connected, S0 is connected to this multiplexer and this multiplexer. So S0 controls this both. When S0 is 0, output is this multiplexer output is D0 and this multiplexer output is D2. Same thing we can see from here also. When S0 is 0, so these two S0 is 0 and output is nothing but D0 and D2. So D0 and D2. But when S equal to S0 is equal to 1, it will transfer, first one will transfer D1 here and second one will transfer D3 here. Similar, same thing we can see here when S0 is equal to 1 in this 2, S0 is 1, so output is D1 and D3. So D1 and D3 comes here. But out of this D0, D1 and D2, D3, which one will go to the output? It is decided by bit S1. So when S1 is 0, S1 is 0 in this case, output is D0 and D1. Okay, so output is D0, D1. This output will be transferred, D0, D1. And when S1 is 1, lower D2, D3 will be transferred, such that when S1, S is equal to 0, means out of these two, one will be transferred. And again, when S0 is also 0, out of this D0 and D1, only D0 will be selected. So these two selects here D0. Again, when S1 is 0, again we have these two to be selected, either D0 or D1. But when S1 becomes 1, it confirms D1. So this is the working principle. I stop here. Thank you.